You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Security Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Log data is one of the most valuable assets in security operations because it captures the footprints of both normal and abnormal behavior across systems. Properly collected and managed, logs allow investigators to reconstruct events in sequence, detect anomalies that deviate from expected baselines, and provide defensible evidence for forensic investigations. When a breach occurs, logs are often the only source of truth showing exactly what accounts were used, which commands were executed, and what data was accessed. Even in day-to-day operations, logs underpin alerting, auditing, and compliance. They tell the story of who did what, when, and where. For learners, think of logs like security cameras in a building. Cameras may not prevent incidents, but they provide essential visibility when something happens. Similarly, logs may not stop attackers directly, but they are indispensable for proving activity, identifying root causes, and supporting effective incident response. The value of logs becomes clearer when we understand where they come from. Operating system logs capture key activities such as logins, process creation, and system changes. Application logs provide visibility into business processes, error handling, and user behavior at the software level. Authentication services like Active Directory or cloud identity platforms generate logs that confirm account usage and access attempts. Network devices, firewalls, routers, intrusion detection systems produce logs that show traffic flows and policy enforcement. In modern environments, cloud APIs add another layer, recording administrative actions, resource creation, and configuration changes in shared infrastructure. Each log source provides one angle of the puzzle, and when combined, they deliver comprehensive visibility. For learners, think of it like investigating an incident in a city. Police reports, CCTV footage, bank records, and cell phone metadata each tell part of the story. Together, they build a holistic narrative of events. Because logs come from so many diverse sources, normalization and schema design are vital to make them searchable and comparable. Normalization is the process of mapping logs into a consistent structure with standard fields, regardless of their origin. Schema design dictates what fields should exist, such as user, source IP, or action, and how they are labeled across different sources. Without normalization, analysts struggle with inconsistent field names, units, or formats, making searches unreliable. With schemas, queries become powerful and portable, enabling correlation across operating systems, cloud logs, and network devices. For learners, think of normalization like translating documents into a common language. Each system speaks differently, but by converting into a shared schema, everyone can read, search, and compare seamlessly. Schema-driven logging is the foundation for efficient analysis, correlation, and detection engineering. Timestamps are another crucial aspect of log usability, and they depend on consistent time synchronization across all systems. Without synchronized clocks, logs from different sources cannot be reliably aligned into coherent timelines. An attacker login on one server might appear to happen after data exfiltration on another simply because the clocks were misaligned. To prevent this, organizations rely on Network Time Protocol (NTP) servers to enforce consistent time across devices. Forensic reconstruction and correlation rules both depend on accurate timestamps. For learners, imagine piecing together CCTV footage from multiple cameras, but each clock is set differently. Events appear out of order, and the investigation collapses. Synchronization through NTP ensures every log has a trustworthy anchor in time, making investigations and detections accurate and defensible. Log retention policies are shaped by competing priorities, forensic needs, compliance requirements, and storage costs. Forensics often benefits from long retention, allowing analysts to go back months or even years to reconstruct dormant attacker activity. Compliance regulations, such as PCI-DSS or HIPAA, often mandate specific retention periods, ensuring logs are available during audits. On the other hand, Storage costs grow rapidly with log volume, especially when storing high-fidelity logs like packet captures. Organizations must balance these drivers, tiering retention so that hot, recent logs are readily available, while older logs are archived to cheaper storage. For learners, this is like managing video footage from security cameras. You may keep the last 30 days on hand for quick review but move older footage to tape storage. Retention policies balance visibility, compliance, and budget. Logs must also be transported securely from their sources to centralized collectors. Secure log transport ensures that attackers cannot intercept, alter, or drop log messages along the way. This involves using encrypted channels, such as TLS, and ensuring reliable delivery mechanisms that buffer logs if network connections fail. Organizations can choose between agent-based collection, where lightweight software runs on each host, or agentless collection, which pulls logs from devices directly. Each approach has trade-offs. Agents provide more flexibility, but they add footprint, while agentless reduces host load but may not capture everything. For learners, think of this like delivering mail. You can either send a courier to pick it up at each house, agentless, or place a mailbox at each location, agent-based. Either way, the key is ensuring mail is delivered securely, reliably, and completely. Protecting log integrity is just as important as collecting them. Logs must be tamper-evident, meaning that any attempt to alter or delete them is detectable. Append-only collectors enforce this by ensuring logs can only be added, never modified. Immutable storage, such as write once, read many (WORM) volumes, adds additional safeguards, guaranteeing that logs remain intact even against administrative misuse. These protections matter because attackers often try to cover their tracks by deleting or modifying logs. Without tamper resistance, investigators cannot trust logs as evidence. For learners, think of it like storing receipts in a bound ledger. If pages can be torn out without trace, the ledger loses value. Tamper-evident logging ensures logs remain credible sources of truth for investigations and audits. Raw logs often lack the context analysts need, so enrichment adds vital metadata. Enrichment might include tagging each log with asset identifiers, system owners, business criticality, or environment tags such as production versus development. These tags allow analysts to prioritize findings. Anomalies on high criticality systems matter more than the same anomaly on test servers. Enrichment also supports automated workflows by embedding business context directly into the logs. For learners, think of this like annotating maps. A plain street map shows roads, but annotated maps highlight hospitals, schools, or fire stations. The annotations add meaning, helping responders prioritize. Similarly, contextual enrichment transforms raw logs into actionable, business-aware evidence streams. Parsing and structuring logs is another step in making them usable. Free text logs may be readable to humans but are difficult for machines to search consistently. Structured logs, often in JSON format, separate data into fields that can be indexed and queried precisely. Parsing transforms messy logs into structured events by extracting key elements such as usernames or IP addresses. Structured logs reduce false positives, accelerate searches, and simplify correlation. For learners, this is like comparing handwritten notes to entries in a spreadsheet. The notes may capture the same information, but the spreadsheet allows sorting, filtering, and analysis at scale. Structured logging makes analytics efficient and accurate, turning noisy text into reliable data streams. Capacity constraints often force organizations to choose between full log fidelity and sampled or summarized data. Full fidelity logging provides maximum visibility but requires massive storage and processing power. Sampling reduces the volume by keeping representative events or summarized metrics instead of every detail. For example, network devices may log every packet or just sample flows. The trade-off is between visibility and scalability. Organizations must decide where full fidelity logs are required, such as authentication events, and where summaries suffice, such as generic traffic flows. For learners, this is like taking photographs. You can photograph every second of a trip, filling albums, or capture highlights that summarize the journey. Both approaches tell the story, but one requires far more resources. Logs only become operationally useful when mapped into alerting pipelines. This means translating log patterns into detection rules and defining escalation paths for analysts. For example, a series of failed logins followed by a successful one might trigger a brute force alert. A new administrative account created in a sensitive environment may trigger escalation to incident response. Alerting pipelines balance sensitivity with accuracy, ensuring analysts receive timely notifications without drowning in noise. Escalation paths also matter. Alerts should flow to the right teams, whether security operations, compliance, or business owners. For learners, this is like fire alarms in a building. The alarm must sound for the right conditions and must notify the right responders. Alerting pipelines transform raw logs into active defense mechanisms. A practical exercise for learners is to enable centralized logging for one application and verify that logs are usable end-to-end. Begin by configuring the application to forward logs to a centralized collector. Ensure timestamps are synchronized using NTP. Add enrichment tags such as System Asset ID, Owner, and Environment. Finally, verify that you can search a specific event across the full logging stack, from application to collector to query console. This hands-on task shows how logging is not just about collection, but about making logs useful for analysis. For learners, it is like testing security cameras. Not only should they record footage, but you must also confirm you can replay and search recordings when needed. Centralized, enriched, and searchable logs are the foundation for effective monitoring, detection, and forensics. Designing log schemas carefully is one of the most important steps in building a usable logging program. A schema defines the fields every log should contain and how they are labeled. The most effective schemas capture 5 key elements: the actor, who performed the action; the action, what was done; the object, what resource was affected; the outcome, success or failure; and the source, where the action originated. These 5 fields give analysts enough context to ask meaningful questions during investigations and hunting. Without schemas, logs are inconsistent. One product might call the same field user, another subject, and another account. Queries become messy, and correlation is unreliable. For learners, this is like designing forms in a hospital. If each department uses a different form for patient information, chaos ensues. With a standardized form, everyone collects and interprets data the same way. In forensics and detection, log schemas create that standardization, ensuring clarity and comparability across systems. Indexing strategies determine how logs are stored and accessed, directly impacting cost and performance. Hot indexes store recent logs on fast storage for immediate search and alerting. Warm indexes hold older logs that are still occasionally needed, but can tolerate slower queries. Cold indexes or archives store the oldest logs in cost-efficient formats, often compressed or placed on slower media. The strategy balances analyst productivity with budget constraints. Without tiering, either costs explode by storing everything as hot, or investigations suffer as queries crawl through massive archives. For learners, imagine organizing your own files. Current projects stay on your desk. Older work goes into a cabinet, and years-old records are stored in the basement. You can still access everything, but the storage reflects how often you need it. Log indexing works the same way, ensuring responsiveness for fresh logs while keeping long-term retention affordable. Log sampling policies help manage high-volume sources without losing critical visibility. For systems that produce millions of events per second like web servers or DNS, logs capturing every event may be impractical. Sampling strategies might involve capturing 1 in every 100 events, summarizing flows, or filtering by severity. The challenge is to preserve enough context to detect meaningful anomalies while reducing unnecessary noise. For example, full authentication logs may be critical for investigations, while sampled web traffic may suffice for trend analysis. For learners, think of this like polling voters during an election. You don't need every citizen's response to understand trends, but you must sample carefully to avoid misleading results. In security logging, thoughtful sampling ensures scale without sacrificing investigative value, striking the balance between completeness and practicality. Structured logging formats, such as JSON, are increasingly the standard because they simplify parsing and analysis. Instead of unstructured text where fields must be extracted with brittle regular expressions, JSON logs organize data into key-value pairs. This allows tools to index logs immediately and analysts to query them precisely. Structured logs also reduce false positives, since fields like username or source IP are explicitly tagged rather than guessed from text patterns. For learners, this is like comparing handwritten notes to a spreadsheet. Handwriting is flexible but messy, while spreadsheets enforce structure and make analysis easy. Structured logging makes systems more predictable, analysts more efficient, and detection rules more reliable. Adopting structured formats at the source is one of the most powerful steps organizations can take to strengthen log usability across the enterprise. Redaction at ingestion time protects privacy while retaining investigative value. Logs often contain sensitive personal identifiers, business secrets, or privileged content. If these are ingested raw, storage systems may accumulate unnecessary privacy risk. Redaction involves removing or obfuscating sensitive fields before logs enter long-term repositories. For example, credit card numbers might be truncated to their last 4 digits, or usernames hashed for anonymity until needed for an investigation. This ensures compliance with privacy laws, while preserving enough context for security operations. For learners, imagine a public report that anonymizes names while still showing roles and actions. You lose some personal detail but preserve the overall story. Redaction balances visibility with responsibility, making log storage both useful and compliant. Retention tiering extends beyond indexes to automated lifecycle policies. Logs may start in high-performance hot tiers for 30 days, transition to cheaper warm storage for 90 days, and then archive to cold storage or off-site systems for years. Lifecycle policies automate these moves, reducing manual oversight and ensuring compliance with regulations. Without tiering, organizations either overspend by keeping everything hot or fail to meet retention requirements by deleting too early. For learners, think of photo storage. You may keep recent photos on your phone, move older ones to your laptop, and archive years-old albums to the cloud. Each stage reflects access needs and storage trade-offs. Lifecycle tiering ensures logs follow the same rational flow, keeping data accessible, defensible, and cost-effective across its entire lifespan. Correlation use cases show the real power of logs once schemas and pipelines are in place. For example, authentication logs can be joined with endpoint process creation logs to detect credential misuse. If a user logs into multiple systems at odd hours and those systems show suspicious processes, correlation reveals a pattern invisible in any one log source. Similarly, firewall logs combined with database queries might reveal exfiltration. The ability to link disparate sources is what transforms logging from raw noise into security intelligence. For learners, think of correlation as detective work. One witness saw a car, another saw a license plate, another saw a driver. Alone, each clue is limited. Together, they prove the case. Correlation turns fragmented signals into coherent stories of attacker behavior. Monitoring for ingestion failures is critical, because missing logs create blind spots attackers can exploit. Pipelines may suffer back pressure when overwhelmed, leading to dropped messages or delayed delivery. Without monitoring, teams may not notice gaps until it's too late. Effective monitoring includes heartbeat checks, queue depth alerts, and dashboards showing ingestion rates across sources. Back pressure must also be managed with scaling strategies, such as adding collectors or optimizing parsing. For learners, imagine CCTV cameras in a building. If a camera goes offline but no one checks, crimes go unseen. Similarly, ingestion failures silently blind security teams unless they are detected and resolved quickly. Monitoring ensures the pipeline remains healthy and complete, keeping visibility intact. Alert tuning techniques reduce false positives and ensure high-value alerts rise to the top. Raw detections may generate overwhelming volumes, frustrating analysts and diluting attention. Tuning adds context, such as correlating with asset criticality or user roles to prioritize alerts. Rules can also be adjusted to focus on patterns that indicate malicious intent rather than benign anomalies. For learners, think of this like smoke detectors in a kitchen. If they sound every time you boil water, you stop trusting them. Proper tuning ensures detectors only sound when true danger exists, preserving trust and focus. In security, tuned alerting pipelines maintain analyst morale and ensure meaningful threats are investigated promptly while reducing noise. Documentation of log sources, owners, and schema in a centralized catalog ensures analysts know what is available and how to interpret it. Without documentation, logs become tribal knowledge, understood only by a few engineers. A catalog lists each source, the fields it produces, retention policies, and responsible owners. This empowers analysts to query logs confidently and ensures consistency when staff rotate. For learners, think of it as a library catalog. Without it, you may not know which shelves contain which books, wasting hours searching. Documentation turns sprawling log ecosystems into navigable resources, saving time and making logs more valuable to the organization. Cost-conscious archiving solutions are essential for long-term compliance retention. Regulations may require logs to be stored for years, but keeping everything in premium storage is unsustainable. Cold storage systems, tape backups, or low-cost cloud archives provide affordable alternatives. The trade-off is slower access, but in compliance contexts, this is acceptable. Archiving ensures organizations remain audit-ready without breaking budgets. For learners, this is like moving old family albums to a safe deposit box. You may not need them daily, but when proof is required, they're available. Archiving strategies keep costs in check while preserving compliance and investigative readiness. Ultimately, effective logging is proactive rather than reactive. Standardized schemas ensure consistency, reliable ingestion guarantees coverage, enrichment adds context, and lifecycle policies balance access with cost. When all of these elements are designed intentionally, logs stop being a burden and become a strategic asset for security operations. They support detection, response, compliance, and forensic investigations with equal strength. For learners, the lesson is clear. Logs are not just exhaust from systems, they are the memory of the digital environment. With careful design and disciplined management, this memory becomes the most powerful tool defenders have to understand, detect, and respond to threats. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.